Welcome again to our course of crystallography and mineralogy. This is the second lecture. Today we will talk about crystal systems and axial systems. We categorize crystal structures according to the axial system to describe their atomic lattice structure. As you will understand later this figure on the right side to see what does it mean axis, what does it mean symmetry, axis, and rotational axis. So the crystal lattice is a three-dimensional network of atoms that are arranged in symmetrical pattern. And each crystal system, basically, you will see that they are consisting of a set of three crystallographic axes, A, B, and C, in a specific geometrical arrangement. And when I say geometrical arrangement, I mean the angles between those axes. You will study only 7 unique crystal systems listed in order of decreasing symmetry as following. And what does it mean in decreasing symmetry? That you will start with the highest symmetry system first, then you go down to the less symmetry system. The first one is cubic system, which is the highest symmetry class, then hexagonal system, tetragonal system, trigonal system, orthorhombic system, monoclinic system, and finally triclinic system. Okay, so let's start with the cubic crystal system first. And this, as we mentioned, it has the highest symmetry elements. We call it isometric crystal system. And iso here, it gives us indication about the homogeneity of the crystal. So, I mean, we have a lot of like same dimensions, same lengths of axes, similar faces, like that. You will see this later. So the cubic isometric crystal system is characterized by the total symmetry. The cubic system has three axes that are perpendicular, A, B, and C. As we saw them before in the last figure, they are equal in length, and they intersect at right angles, 90 degrees to each other. So it's very simple. A, B, C equal lengths, and they intersect or they cut each other at right angles. Here is very clear. The figure in the middle shows the cube isometric unit cell with the three axes A, B, and C. And on the right side, you'll see the relationship between these angles, which is alpha equals beta equals gamma equals 90 degrees. Okay? And then if we just open this cube, you will see the 6 faces on the left side. Same thing we will do for the next cube, the hexagonal crystal system. Here the angular relationship between the axes A, B, and D, we keep C actually for the vertical one. It's the degrees, the relationship or the angle between the horizontal axes is 120 degrees, and the C axis intersect all those horizontal axes perpendicularly. See, the C axis can be shorter or longer. Be careful about that. Don't think that's always longer. It's shorter or longer, but it's not equal. Okay, and same thing here. You see the hexagonal unit cell in the middle, and the angular relationship between the axis on the right. Then you have the flat hexagonal system on the left, which has like 8 faces. Tetragonal, same thing. So we are not going to repeat this stuff. You can just read it. But be careful about the C-axis, and tetragonal and hexagonal is shorter or longer. So if the C was equal in length to B or other, then we would be in the cubic system back again. Here is the tetragonal, same story. trigonal system. Trigonal crystal system has 6 faces, 12 edges, and 8 vertices. And here's the shape, or here's the figure for the trigonal system. But you have alpha equals beta equals gamma. Also, all of them, they don't equal 90 degrees. A equals B equals orthorhombic crystal system. Here it is also known as rhombic system, and 3 axes. All of them at right angles and all 3 different lengths. So A doesn't equal B, doesn't equal C, but the angles between them is equal, which is 90. So if any of these axes was of equal lengths to another, then we will go to the trigonal system. Here is a figure that shows the orthorhombic system. We have orthorhombic unit cell in the middle, and you have the axes on the right and the flat shape on the monoclinic system. From its name, you can see it has 3 unequal axes, but the A and C crystallographic axes are inclined toward each other at an oblique angle, and B axis only is perpendicular to A and C. Same thing, if C crossed at 90 degrees, then we would be in orthorhombic system. Here is a figure for monoclinic crystal. Triclinic system, same thing. If any of the 2 axes crossed at 90 degrees, then we will go to or move back to monoclinic crystal. You just have to read them carefully and you'll understand that very well. Here's a figure for the triclinic. And so the 7 crystal systems, as you can see here, simple cubic, tetragonal, orthorhombic, rhombohedral, monoclinic, triclinic, and hexagonal. Okay, in the next lecture, we will talk about the crystal system to understand more about crystallography. Thank you. Have a nice day. Bye.